Okay, quiz 1, question 1. You plan to open a bank account by depositing $500 a day at the end of each year for the next 9 years. So you have an annuity, but it's described as being an annuity due because the payment's becoming at the beginning of the year, right? So we deposit it today, and at the end of the year is also the beginning of the next year. So that's the big thing here, is you're describing an annuity due even though it's at the end. And so the cash flow looks like this. At time 0, you're starting out with 500, and at the end of year 0, when it begins year 1, you have another 500. So you have 10 payments of 500. So there's two ways to view this. We can set this up by just figuring out what's the value at the end of 10 years. And so we could do that by using a present value, future value, to where we have a present value of 500 times 1 plus 0.02. So we have 1, again, that 2% rate of return to the power, and this is where it's going to be tricky. So we know it's going to grow for 10 years because we have 10 at the end here. So what we could say is equal to 10 F4 minus the current period. So as we scroll down, we're getting 10 minus 1, 10 minus 2 to account for the years remaining. It's important to put that in parentheses. So we can see if we deposit $500 at time 0, at the end of the 10 years, it's worth $609. We can drag that down, and then all we have to do is sum these values. So we'll hit Alt equal, sum them up. So you can see we end up with a value of 5584.36. So you can see the formulas. All right. So again, remember this B13 minus B3, it's like saying 10 minus 0, which means there's 10 years to grow. So then at this one, it's 10 minus 1, which means there's 9 years to grow. And then 10 minus 2, there's 8 years to grow. So what we're saying is to the power of 10, to the power 9, to the power 8, to the power 7, power 6, and so forth. By the time we get down here to year 9, the $500 we put at the beginning of the year only has 1 year to grow. So 10 minus 9, 1 year. And that's why it's worth 510. It's got a 2% increase. The other way that we can approach this is using the future value function, but this is a little bit more confusing, I think. So we know our rate is 0.02. We know that it's going to grow for 10 years, or for 10 periods, I should say, because we can see here from 0 through 9 describing the cash flows. We know that our payment is going to be 500, so we're going to mark it as a cash outflow. But where it would get confusing is you would normally think, okay, I should put this 500 as a present value today. And if you do that, you're going to get the wrong answer. So if you did 500 today, but then you marked the other 500 at the end of the period, it would show up, and I'll show you. Let's say you put 500 a day and then 500 at the end of the period, so you put a 0 here, your value is going to be off because you're including an extra payment. If you change this so where it's only 9 payments, because notice this value here is $500 larger than this one. However, if you turn this to 9, there's one less period of compounding, and you see that your answer is short. So the way to solve and get this one correct is to say, no, we're not going to start out with a present value of 0. We're going to have 500, but we're going to change this to an annuity due. So the payments occur at the beginning of the period. And then what we're going to do is, instead of having this grow for 9 periods, we're going to have it grow for 10. So then you see we get the correct response. So 2 ways to do this. We figure out either the cash flow by each year to get the right response, or we can use the future value function.